Alright, today we are going to look at your topical practice set 2 for electricity. Alright, we're starting off with open-ended questions. Let's take a look at a question. Sammy set up an experiment as shown below. When the clips were connected to the container, the bulb lit up. State whether liquid P and material Q must be conductors of electricity. Give a reason for your answer. So conductors of electricity just means that they allow electricity to pass through. Okay, now this is a very fundamental concept. I'm going to explain it one more time here. When you say that you are a conductor of something, it means that you allow this particular item or substance to pass through. So when you say that you're a conductor of electricity, it means that you allow electricity to pass through. Okay? So the first one asks you, must it be a conductor of electricity, liquid P, yes or no? So we know that in order for it to be a complete, in order for the bulb to light up, there must be a closed circuit. So there mustn't be any gap. So when we take a look at it, okay, I'm going to use red to highlight. So the battery source comes from here, okay, and where is the point of contact? It's actually with your container, right? And this is material Q. Now, because the contact of the wires is with material Q, it doesn't matter if your material P is a conductor of electricity or not, right? Because it is not in direct contact with the wires. So the one that needs to be a conductor of electricity would be your container Q. Okay, so the electric current can then flow this way. Okay, making it a complete circuit. So it doesn't matter whether or not your liquid P is. Alright, so what is it that you need to tell me? You need to tell me that the answer is no, and you have to tell me why. So in your answer, you should state that the metal clips are clipped to the container or in direct contact with the container. So because of that, you don't need the P to be a conductor. You just need Q. So answer no, the metal clips are clipped onto the container. Therefore, the container, which is made up of Q, closes the circuit. Allowing electric currents to flow through the circuit. Okay? So this part is very important. Okay? And then you state the purpose. Alright? Whereby it closes and then electric current can flow through. So therefore, if you can see, this part over here is actually your C, and this part over here is your E. Okay, the O part does not need to be mentioned in this case because they already told you what is the O. The O is actually your light bulb lights up, right? They never ask you what will happen, okay, and then explain why. This case, they tell you what happened and they ask you to explain. So the outcome is already stated, but it's perfectly fine. Okay, you can add that in. Therefore, the light bulb would light up. That is your own. Next, so must it be a conductor for Q? Answer is yes. Absolute yes. So why? Okay. So actually it's a similar idea once again. So yes, since the clip or the metal clips were attached to the container, material Q must be a conductor of electricity in order to close the circuit. And allow electric currents to flow through. The circuit. So once again, you have your C over here, and then your your E is over here. Okay, moving on. Okay, in circuits P and Q, all the bulbs are lit. Okay, every one of them. In the table below, write down the number of bulbs would remain lit when one of the bulbs in each circuit is blown. Okay, so for P, if just one of it is blown, all right, the maximum number you can have is 3. Now the reason is because it's arranged in a parallel circuit. So for example, if we say that this is blown, okay, so I'm going to erase it, you will actually see that this electric current can still flow through this, no issue. So 3. Now, for Q, it doesn't matter which one. Okay, pick any one. Let's just say we just pick this one over here. The maximum is 2. Because of the gap over here, there is no way I will be able to cross from here to here. So therefore, your electric current will skip this pathway, go through this 2 and return to the battery source. Therefore, the maximum is 2, no matter which one bulb you choose. Okay? So answer 2. Now, in circuit R below, all bulbs, okay, B1, B2, B3, B4 are lit. Now, in exam, right, to show that it's lit, right, this is for me personally. You can choose not to, but I prefer to actually draw 3 lines to actually show that they are lit, so that I know, okay, they are working. Okay, and use pencil please so that you can erase, and then because sometimes you need to trace more than one time, or you need to make certain changes as the question develops. Okay, now write down the smallest and largest number of bulbs that would remain lit when one of the bulbs in circuit R is blown. Give a reason. So what this question is trying to ask you is to find out which bulb, when blown, will give you the largest remaining number of light bulbs being lit, and which bulb, when blown, will give you the least amount of light bulbs lit. So the smallest number you could possibly get is 0, and the largest number is 3. Okay, I'm not saying that this is the answer, I'm telling the possibility, because one of it has to blow, right? So the maximum number you can have lit is 3. So to actually do this, right, you need to actually color code it to make it easier for you to see. So the green color, okay, I'm going to show you how electric current runs in this case first. So it always runs from the positive, okay, to the negative. So it will go through B1 and then it will split. Okay, you go through B3, at the same time you go through B2, reach over here, these two will come together, go through B4 and then return. So if you take a look at it, right, okay, there are 2 spots here that is like a common expressway. There's only a single route. So I'm going to highlight for you. The part that is a single route will be in green. Right? You will notice that there is no other way. When the circuit goes towards this parallel part here, it has to pass through bulb 1. So if bulb 1 is blown, that's it. The whole entire circuit is gone. None of these bulbs will receive any electricity because there is a gap. Right? And if B4 is blown, okay, the same thing happens. Your electric current can no longer return to your battery source. Right? So because of that, there is no complete circuit for any one of these bulbs. Okay? So I'm going to use red color to code this, so you know. So therefore, the smallest number of bulbs remaining is 0. Okay, and then we craft the answer for this, because now we understand why. So you would say that, okay, so B1 and B4 are arranged in series. So definition of series is basically where the bulbs are arranged one after another and there is no alternative pathway. So you see there's no alternative pathway. Once it's blown, it's blown. Okay? So when either B1 or B4 is blown, there is, okay, sorry, let me paraphrase this, is blown, the circuit is open. Okay, as such, electric currents cannot flow through the circuit. Hence, no bulb can light up. Okay, so I'm going to highlight for you in different colors the CEO. So this is C, this is O, sorry, this is C, this is E, and then this is O. Okay? Please annotate your CEO. C, CEO. Alright, I cannot stress the importance any more than what I'm doing already. Showing you how explicit CEO can be used. Right. So then after that, they ask you what is the largest number. So you think about it in a logical manner. If it's largest number, right, I have to get rid of one bulb that is not, okay, on the parallel lines, okay? Sorry, that is on the parallel lines, such that it does not affect my current flowing in one complete circuit. So definitely the bulbs that will be affected will be one that is arranged in a parallel arrangement. Okay, because it's parallel arrangement, bulbs in parallel arrangement that have alternating pathways, correct? Then my current can at least go somewhere else. So if you take a look at this, you will notice that your 2 and 3 are the ones that are parallel to each other. Okay, they are parallel to each other. So I only have to get rid of one, right? So for example, if I get rid of, say, B3, okay, what would happen is that electric current will flow through here. It will flow up to B2, to B4, and then back. So how many? 3. Okay, and if I do it the other way round, okay, it will be the same number, because it's just that this time round I'll flow through B3 instead of B2. Okay, once again it's 3. That is the maximum anyways, correct? Because you have to get rid of 1. So I would have already gotten my answer. So how do we craft this? So the answer would still be 0. Sorry, 3. Okay, and we can say that B2 and B3 are arranged in parallel. Okay, so when either B2 or B3 is blown, the circuit the current still has an alternative electrical path. And the circuit is still closed. As such, electric current can still flow through the circuit. And the remaining 3 bulbs will light up. Okay, so where is your CEO? So your CEO is here. Circuit is still closed. Electric current can still flow through. And your O is here. C, E, and O. Please annotate. Now, this question is a little bit different, not so straightforward. Okay, you have to talk about something new, which is the alternative pathway. Now, I would like everyone to memorize this phrase, alternative path. Okay, so this answer is used to describe or used to explain for parallel bulbs arranged in bulbs arranged in parallel. What happens when one of them blows and the other still can light up? Okay. Alright? Okay, so please memorize this statement. Okay? Now, so basically, this statement is used to explain, I stress again, what happens. Okay, so if in a question, I just want to elaborate a little bit more. So for example, if in a question, they give you something like this. Okay? Okay, this is obviously just to exemplify to you. Okay, please do not follow this drawing. This is a bad drawing because they have gaps and basically I didn't use a ruler. So for example, they ask you, oh, you know, bulbs A, B, C were lit up, but then bulb B blew. Okay? What will happen? Explain your answer. So obviously, in this case, if bulb B blows, you would say that bulb A and C remains lit up. Then why? So because bulb A, B, and C, or A and C are arranged in an in a parallel arrangement, okay, electric currents still have what? Alternate electrical pathways. Okay, and the circuit still remain closed for bulb B and C. Actually, to be very explicit, to tell me for which bulbs. So then electric currents can still flow through the circuit, alright, and bulb A and C will remain lit up. Okay? So this is very important for explaining parallel arrangement. Now, one other thing I want you to take note, right, of this question is that another key thing that you need to realize is these two questions are comparing arrangement of bulbs and how it affects, okay, the current flow when one bulb is blown. So you have to mention to me how they are arranged. Alright, because it is the arrangement that affects the outcome. You got it? So please, like I told you already, many times of students will tend not to talk about the arrangement. And true enough, students, take a look at your answers now. How many of you actually did not write down the arrangement? And this was an error that I spotted even before you did this question, right? I told you when I was going through my explanation, my presentation of slides, that it is very important to state the arrangement in your answers. But yet, many of you did not do so. Okay? Next. Okay. Zen designed an electrical system for a fan and air conditioner in his room, as shown. The system prevents both fan and aircon from being turned on at the same time. So W is an iron bar placed inside of a coil wire. Straight away, without even thinking much, I already know what is this going to be. Okay, this draws on the concept of P4 magnets. This is an electromagnet setup. Okay, P and Q are two iron pins, alright, in contact with each other. Pin P is fixed, pin Q is attached to a metal rod X and can move sideways. So we know this one can move sideways, this way and that way. Alright, so they tell you the iron pin. So okay, so from here I roughly know already, this one will probably be attracted to electromagnet W. But we also have to read and think further. This is just my initial thoughts when I see these key ideas. This is also what your brain is supposed to be thinking. But you should not jump into conclusion. What I'm saying is that all this, it should flag out certain things. Okay, I'm thinking out loud for you to see how I think. Okay, then they tell you, on a hot afternoon, Zhang closed switch 1 to turn on the fan. Okay, he felt that the room was still too warm and closed switch 2 to turn the air conditioner on. What will happen to pin Q after switch 2 was closed? Give a reason for your answer. So when pin 2 is closed, okay, so electric current will flow from here, over here, back. Okay, this would then become an electromagnet, right? So does this actually coincide to what you have taught in the beginning? Yes, it does. And if it's an electromagnet, it's usually to attract something. That will be your Q, right? So you have to answer this question and be very careful. Many students didn't talk about the outcome being pin Q. You tell me that the air conditioner will turn on. But the air conditioner is not the outcome. The outcome they want is what happened to pin Q, CEO. So the O is talking about pin Q being attracted to the electromagnet. Not so much about your aircon being turned on. You realize? But some of you actually made a very careless mistake. Something that was repetitive in the previous topical practice that we have done. Alright? So how could your answer be? So when switch 2 is closed, okay, then you have your first C. The circuit is closed, right? And electric current can flow through the circuit. Then after that, my outcome. Alright? So the outcome of it would be my iron rod W. Okay? So W, iron bar W, or iron rod, iron bar. Okay, sorry. So iron bar W becomes a magnet and attracts pin Q. Okay, so can you see once again my answer is so nicely phrased. Okay, my C is here, my E is here, my O is here. Please annotate. Okay, and then yes, I can take all three, and the teacher will take all three, and your peer will take all three, and they'll give you many stars for such a perfect answer. Next, give a reason why the fan was turned off when James closed switch 2. So they already tell you the outcome. So you will need to talk about C and E. Is the circuit open or is the circuit closed? Can electric current flow through? The electric current cannot flow through. So if you take a look at it, okay, when you close switch 2, okay, because Q now moves over to, let me erase away Q first. Okay, now Q moves over to this side. Let me draw back Q in. Okay. Can you see that there is a big gap here? So in your answer, you need to say, when switch 2 is closed, okay, what happened is that Q is attracted to, okay, Q is attracted to W. Hence, the circuit is no longer complete, or the circuit is open. Electric current cannot flow through, alright, causing the fan to be turned off. That's your O. So like I say, it's okay to repeat the O, but in this case, because they didn't tell you what's the outcome. Alright, but I'm going to be complete and I will write for you the full answer. So when S2 is closed, pin Q is attracted to W, which causes the circuit to be open. Electric currents cannot flow through the circuit and the fan is turned off. Okay, so I'm going to once again bracket it for you. Circuit to be open or closed, this is my C. Electric current, this is my E. And fan is turned off is my O. C, E, O. Yes. Sorry, I missed up. This one should be becomes an electro. I forgot the word electro. Okay, this is important. Thanks for highlighting. Okay, magnet and electromagnet are different, so please make sure the word electro is there. Okay, let's inch on to the next question. Now, suggest a way why Zen designed the system so that the fan and air conditioner would not be turned on at the same time. This is a very straightforward question. It is basically, okay, in order not to waste electrical energy. Okay, so it is to ensure that only one appliance is turned on to save electricity. Okay, this question is rather well done, thankfully. Next. Okay, an experiment is set up as shown in the diagram. Okay, the nichrome wire becomes hot when the switch is turned on. Now, this is a novel question that you have not seen before. Okay, but it's okay. Let's take a look at it. Now, what does this experiment tells you about liquid Z? So, whenever you do this kind of question, ask yourself, alright? Okay, trace the flow of the electric current. So from positive, okay, it needs to go past these two, go through the nichrome wire to the switch and then back to the battery. So it tells you that because these two metal plates are separated from each other, it tells you that there must be something that is connecting these two plates. Right? And whatever that's connecting these two plates has to be a conductor of electricity. If not, electric currents cannot flow through, right? So there you have it. The answer would be that liquid Z is an electrical conductor. Okay? So liquid Z is a conductor of electricity. Please be careful. Some of you say conductor of heat. No. Okay? Now what will happen to the nichrome wire if the number of batteries is increased? Now, take a look at the question. They told you, what happens to the nichrome wire? It becomes hot, right? So basically, if you have more current flowing through it, it will actually become hotter, right? Or the temperature of the nichrome will become hotter, okay? Now, I'm not going to fault you for the part that you didn't write down turn rate, because that is something that you wouldn't know. But some of you, okay, none of you wrote that, but you know your tungsten wire, it actually glows when electric current flows through it, and that's how you get light across the filament. So if you draw a parallel to that, you will know that somehow your wire would glow, turn red, okay, and then increase in temperature. However, I'm just marking you based on become hotter because that was what was stated in your stem of the question. Additionally, I would also like you to be careful. You need to have a comparison. So if you just tell me it becomes hot, you don't get any marks because the question it tells you becomes hot. It needs to be hotter. It needs to be hotter. Okay? Next, give a reason for your answer. So the reason for your answer would be that it actually has more currents flowing through it. Okay? So this one, right? Okay, you want to say that with more battery, more current will flow through the circuit. Causing the nichrome wire to turn red and heat up. Okay? Right. Next, the diagram below shows a circuit and what happens to a lamp when three rods A, B, C are placed one at a time across P, Q. So your P and Q is here. So what it means is that they will take different type of rod A, rod B, rod C, and then they put it here. And then after that, they tell you whether or not the light bulbs will light up. So very straightforward. You know that for B, it lights up because there must be a complete circuit. So in order for it to be a complete circuit, okay, B needs to be a conductor of electricity, right? So your answer would be B. And the reason, use CEO. Very simple. So you go B or rod B closes, okay, the circuit which allows electrical currents to flow through the circuit, okay, allowing the light bulb to light up. Okay? So once again, CEO. Your C is here. Your E is here. Your O is bulb light up. Okay? Okay, this is a very tricky question. Actually, it's a very simple question, but many of you wrote it wrongly. Okay? In another experiment, some wax was placed on top of the same three rods. The three rods were then placed on top of a hot surface as shown below. So this is the hot surface, and what it meant is that these items, the heat will actually pass on to rod A and eventually to the wax. Okay? Now, it was observed that the wax on B melted first. Okay? Followed by that on rod C. and then rod A. What conclusion can you draw about the conductivity of A, B, and C? So like I told you, your heat will first travel from the hot surface to your rod, and then from your rod to your wax to melt it. So obviously the one that melted first, alright, will have the best heat conductivity. Okay, followed by the one that does not conduct heat that quickly, alright, will melt wax at a slower rate. So you have to talk about all three. Now, because there are only three, you only have to talk about two. So we know that since B melted first, B would be the best heat conductor. And we know that A was the last. We know that is the poorest conductor. So we just have to talk about these two. Then the examiner will understand that since the best was B and the worst was A, C must be in between. Okay, but you have to talk about all three. Okay, so I would how to phrase it. So B is the best heat conductor, while A is the poorest conductor of heat. Okay? Now, the last question is the one that many people did it wrongly. Okay? You talk about increasing conductivity. No, you cannot say this. You cannot say that, oh, if it's a, okay, some of you actually said something like, oh, the better the conductor of electricity, the better it would be a heat conductor. How do you know? Did this experiment in the first place over here measure how good of a conductor? No, right? It's either a yes or a no. Do you realize? It is not a rate. Alright? So because it is not a rate, you cannot assume that, oh, the better a conductor of electricity is, the better it is of a heat conductor. It doesn't work that way. Okay? So you can only conclude that if a material is an electrical conductor, it is most likely to be a good conductor of heat. Okay? Okay, how do you know that? You draw in comparison, no? So you see, the first one over here, okay, B is a conductor, and yet B is also the first one, okay, to allow the wax to melt. This will tell me that heat actually travels the fastest. Okay? Now, let's take a look at the last part here, your exit card. Use ruler and pencil. Okay, seriously. Now, so match the characteristics. Okay, very straightforward. Okay, so for series, it will be this one over here. Okay, you see there's only one flow. Okay, parallel looks like this. This is a circuit diagram. Electric current, right, can only flow in a closed circuit. Okay, electrical conductors allow electric current to flow through them, and electrical insulators do not allow electricity to flow through them. Now, I want to stress one very last important point. You can only use insulator. Insulator can only be used for electrical conductors, and you cannot use this term insulator for heat. Okay, heat materials. No such thing as a heat insulator. All materials will allow heat to pass through them. It's just how fast or how slow.